In this video, I will show how I developed several WAEVE programs, WAEVE being a technical analysis tool I developed, in combination to give us an ensemble of estimates to give us a 30-day trend. This ensemble is pretty much like what hurricane forecasters use when predicting the path of a hurricane. And this is not to be, again, confused with the WECA ensemble functions like bagging, stacking, and voting, but it's somewhat similar. A lot of the logic that we see here have already been presented in two other videos I did. The first one is on the weighted average expected value estimator, and the second one was just previous to this, is the ensemble logic I used with WECA estimates to predict a 30-day trend. Starting with the technical analysis tool I called WAEVE, which again was presented 2 videos ago. I took the state table class and renamed it the Wavetable key, and created a super abstract class called Wavetable, which contains the common attributes and methods used by the subclasses that extend it. The Wavetable class contains several methods. The 4 most important are accuracy test, get transition count, get what I can see, and what is the state transition percentage change. The method get what I can see is abstracted because the attributes of the subclasses are independent of other and of the main class. So that class is really the only one that's abstracted. All of the subclasses of Wavetable do 2 things. The first is to build the attributes based on the function that they're using, the technical analysis function that they're using the get what I can see method, which defines the attribute values for each day in the test, training, and production cycles. The main method, the main static method, tests all these combinations to find the highest or best percentage from the expected value table. These best parameters or best values are stored in a database. I use a basic CSV file for each of the 30 days. And then finally, when we're in wanting to build the actual chart of the 30-day trend, the method in the subclass is called get all averages, will produce the best guess for each day. But I'll present more of that towards the end of this video. In each of the Wavetable subclasses, there's an inner class called best parameters, which extends an abstract class called abstract best parameters. It is used by the subclasses to store the best attribute values for the technical function used by that subclass. The first parameter is a little different. It actually is the best return value for the look ahead for that class, and that will be described in the next slide. The remaining parameters are for the technical analysis function themselves, representing the parameters that return the best value. For example, a MACD will have 3 parameters for the fast, medium, and slow periods. These values are stored in a CSV file, and each line in the file represents the look-ahead day count. So, for example, the 10th line in the file would be the 10th day look-ahead parameter. As for the first parameter, which is the best return value for the function or class, this will be used in the weighting of the predicted value when making the 30-day trend estimate. As for the subclasses of Wavetable, these programs do the grunt work of finding the best parameters for their respective technical analysis function or multiple functions. Several will be posted up at sourceforge.net in the WAEVE Ensemble subdirectory. I have several programs I've already written. Double moving average, linear regression, MACD and RSI, momentum and RSI, stochastic momentum index, which is not part of TA-LIB library, but it is the code is available in the utils subdirectory. And finally, there's one other subclass for Williams percentage R, along with the ultimate oscillator done by Williams. But let's take a quick look at momentum and RSI to give you an idea how these puppies work. Let's take a look at the superclass wavetable, where we store the weighted average expected value for each attribute that we find. It's again a average for that attribute value. The attribute being like if the RSI was above the previous data RSI, or the MACD was lower than the previous MACD. Lots of things are going on in this master class, but again, you can find all this information in the program, or in the video I presented about the wavetable, which is 2 before this one. The most important thing going on here is that it's exactly the same. So let's go over to the momentum and RSI subclass. Momentum and RSI here, again, what we do is, one of the things we have is a file name prefix to identify the file, the CSV file, where we will store the best parameters value for each of the 30 days. Some of the attributes, again, are the momentum value for the symbol that we're tracking and the RSI values. Here is the best parameters inner class, which will be storing the periods, in this case for the momentum and RSI. Again, there's 3 parameters for this class. The first one being the best returns value that we see here. And here's where we're parsing it out of the CSV file. We get the best return value for that day, the MOM or momentum period, and the RSI period. The main static class is will build a CSV file for us. The CSV file, since some of these parameters or some of these programs take a long time to run, you're able to stop it and restart it, and it will pick up where it left off. That's what's pretty much going on right here. Here's where we build or find the best parameters for each of those 1 to 30 days, and in this case we'll print them out to the file, and we'll close it. Okay, get all averages is used at the end when we're trying to do the actual prediction of the 30-day trend. This is the static class to get the best parameters from for main, and we're going to do a MOM period check between 2 to 10 periods and an RSI period check from 2 to 15. It will find the best parameters. We build a parameter string. This first string here is, or this first value here is the best parameter value. So we just simply initialize it to 0. The program's not going to set it until the very end. And then we pass along to it the MOM period and the momentum period and the RSI period that we'll be checking. It goes through and does the check to find the best value, and if it's better, if we get a better value than what happened before, then we'll just simply store the best parameters in a return value and reset the best value. That's pretty much it. That's pretty basic and straightforward. Again, the constructor will initialize or instantiate the TA-LIB core object, and then build the momentum and RSI values for each of the periods that we pass through best parameters. Get what I can see. Again, this is where the attributes for the file are stored, and again, you can find all this information in the previous video. From here's what the, for instance, the MOM and momentum and RSI CSV file looks like. Again, the first attribute in the CSV file is the best return for the momentum period and RSI period. And what is also interesting to note is as we go out further in time, the best return value gets better and better. And early period checks, like for 1-day look ahead and 2-day look aheads, are pretty low and not all that great. So once that's all done, we use a program called Average of All that does the actual, we'll print out the 30-day trend and present it as a Java 2D GUI. It will go through each of the functions of the subclasses of Wavetable, in this case, double moving average, MACD RSI, momentum and RSI, so on and so forth, and store all of the averages and update those averages using a weighted average function of the best return value for each particular day for each particular class. And as each program returns the values in all averages, it uses a generic class down here called print averages. At one time it just printed them out to the console, but now it sends them to a object that will be used to present a TA-LIB function. So let's take a look and just run it here. And there it goes. And it will generate a 2D graph. And here's a copy of SPY. As of December 2nd, the data from December 2nd, last night, President Trump said that China deal probably won't happen until after the elections, and he gave the French a finger for what they said about NATO. Here's the 30-day trend of the average of 7 different methods that were used. And the black line there represents the average of all 7. So that's a trend for the next 30 days. Says it's still looking up, even though the past couple of days it's been down, and today, as of December 3rd, it's down. So that's it. On to the next time. Hey, listen, if you like what you see, please subscribe. Please make a comment and let others know what you think. Thank you very much.